more before you leave.
I was going to say.
Hungry, I am not taking a dozen pizzas.
Yeah.
That's great.
Yeah. Anybody, feel free to go anytime. Go grab pizza, drinks, whatever. You all saw the restrooms outside, all that good stuff. Fantastic. So my name is Jeremy. I'm going to get started in just a second here. Hope people don't mind. We're going to be recording just for putting this on YouTube afterwards, so you can share with anybody who might be interested. We're just going to be recording me, so you won't be on the video, and then we will cut off the Q&A section, so you can feel free to ask anything. Just wanted to kind of like give full disclosure to everybody that we are like recording, but again, it won't get you in the recording. Cool. All right, good deal. Awesome. As Steve, right? Mm-hmm. Yes, as Steve mentioned, talk's going to be about 35 minutes. It's an interesting topic that I've been kind of exploring a lot over the last 6-month period or so, having this talk in different forms and in different formats. You guys are lucky enough that you get kind of the convergence of 2 different presentations that I've been giving on this topic over the last few months, where I kind of finally figured out how the 2 ideas that I had in my head sort of fit together. It's the first time I'm giving this version of it, so you're my guinea pigs for this version of the talk. I gave a partial version of it, like half of the topic last week at Black Hat Asia. I will say it was very positively received, so that was encouraging. So I know that at least half of the content is decent, and the other half we'll see. And like Steve mentioned, I'm definitely going to try to leave a lot of time at the end for Q&A. I don't think I'll go more than about 30 minutes as we talk through this, because I don't think I have more than 30 minutes of stuff to say on this topic. This is just a little bit about me. I've been in IT and cyber for like 27-ish years at this point, showing my age. I spent some time at AWS, our esteemed host for the evening, a brief period in the early days of cloud, when one of the first questions we had to ask or answer was, why is a bookstore trying to rent me servers? And a lot of the common misconceptions around cloud computing at that time and misunderstandings about what the potential of the cloud really was. I spent some time with all those companies that you see on there. I think the most interesting thing is that I kind of spent the first half of my career as really a hands-on keyboard IT and cyber practitioner. I have gone through data breaches. If you're super curious about it, Google Modern Cyber Podcast Data Breach. We have a series on there where we talk to people about the worst data breaches that they're willing to discuss in a public forum, typically anonymized in terms of what company or organization they were with at the time, what happened, what they learned from that event. And I went first on that series, so I shared the worst data breach that I ever suffered in my career. It's about 15 minutes, a little bit fun to listen to if you're ever curious about it. Overview, what we're going to talk about today, we're going to talk about kind of where we are with AI. And then we're going to talk about this concept that I've been kind of conceptualizing in my head, the double-edged sword. So AI brings a lot of positives for cybersecurity, but it also brings a lot of challenges for cybersecurity. So we're going to talk about both aspects of it, also really looking at what we're seeing in the real world right now, like what is actually happening, not just conceptual or academically possible, but what is actually happening. And by the way, do feel free to take photos of anything that you find interesting, or hit me up afterwards. I'm more than happy to share the slides with anybody who wants. Awesome. So one of the 2 concepts, plenty of seats over here on the other side. One of the concepts, one of the frameworks that I've been kind of thinking about as I've gone through my own career, I've witnessed kind of like 4 stages of digital, quote unquote, digital transformation. Everything from the early adoption of desktop PCs and, let's say, small office networks, and what could we do with networked PCs in an office environment? Everything from printing over a network and file sharing and collaborating on documents. Back in the old days, when what that really meant was you went on a file server, you opened an Excel spreadsheet, you made some updates, you saved it, and then the next person opened that same spreadsheet. And that's how you kind of collaborated on a document. Everything from that initial phase to then cloud computing to, let's say, like modern cloud computing to where we are today. And what I've noticed is that with each step along the way, every new technology brings 2 types of risks. It brings your first-party risks, which are the things that you are in control of, and then it brings your third-party risks. So if I think about kind of first-party risks, you can think about, let's say, the first wave of desktop computing. And what did we have as some of the first-party risks? And again, like these are things that you're responsible for. Well, you're always responsible for, let's say, your own environment. Common example here, you're responsible for the patch level of your operating system. If you're running an old version of your operating system that has a bunch of vulnerabilities, that's on you. Now, a threat actor might exploit that, but you are fully in control of what version of the operating system that you're running. Same is true for any third-party software that you're running, et cetera, et cetera. Then when we move to the cloud, you're responsible for how you use the cloud. I'm sure everybody in this room is familiar with the shared responsibility model. See some nodding heads? Yes. You remember the whole phrase, what is Amazon responsible for? Security. There we go. And what are you responsible for? That's right. Your own security in the cloud, right? So that is kind of that shared responsibility model. So you are responsible for the security of your own resources and your own assets within the cloud environment. Similarly, as we got into what I would consider kind of like modern or cloud native architectures that tend to be more microservice oriented and built on things like serverless or containerized environments, you end up having APIs. That's the primary data interchange for different parts of your application stack to talk to each other. Similarly, you are responsible for how secure or insecure your APIs are, right? So we go through these waves of transformation. Each wave brings a set of first-party responsibilities and first-party risks that you control. Each wave also brings third-party risks, right? And these are risks that evolve outside of your control, but they might impact you. So when we talked about, let's say, like that early transition to desktop computing, we had our first wave of viruses and worms and so on, and we'll talk about a few of those in a minute. Then we also, when we got to, let's say, like putting websites online for our companies for the first time, we had some risks around people taking our websites down, DDoS, denial of service attacks, or let's say things like your content getting scraped as you put it online. That could be anything from your product catalog to your intellectual property, et cetera. So these are things that are, again, happening outside of your organization. They impact you, but you're not necessarily in control of what's going on. You can mitigate them to some extent, but these are, again, like your third-party risks. Bots are typically the things responsible for scraping your environment. And sorry, just last thing that I'll mention here, how many people have played around with, let's say, like just putting something online right now, whether in a cloud environment or let's say on one of your networks, and then seeing how long before it starts to get traffic? Has anybody played around with that recently? Let's say in the last like couple years? Yeah? How long before it started getting traffic? Yeah, a few minutes. Yeah, instantly. I mean, that is roughly true. So we build a bunch of security software at Firetail, and one of the things we do is we put stuff online for testing purposes, and we see traffic typically within about 2 to 3 minutes. And in that time period, one of the things that we see right now is we see more and more intelligent traffic. We're going to talk a little bit about that as we get into it, right? So first-party risks, third-party risks. So how does this impact you as you go through kind of, let's say, phases of digital innovation or digital technology? We start with on-prem. And at the beginning, we're kind of in a very server or client server-based environment. But think about those early days of IT, right? For those of us who are as old as me and have been in this space for a little while now, what did you see? Well, remember how magical IT used to be? How you used to have to go to the quote unquote IT guy, and I say IT guy because stereotypically it was a guy, especially in those days. And even if it wasn't a male, you always refer to that person as the IT guy, for better or for worse. But you kind of had to go to the IT team to get things done, right? You didn't have control. Somebody else within your organization controlled the IT environment. And you focused on kind of keeping threat actors out of your environment. So perimeter-oriented defense was a very common strategy at that point in time. And the first wave of tools that really got deployed to mitigate some of those third-party risks were things like firewalls to keep people out of your environment, or you see EDR here, but actually like in those days, it was mostly endpoint protection and antivirus and anti-malware type of solutions at that point. SIM kind of evolved at some point in DLP. Let's say like in the later phase, as we started to get towards the cloud, DLP started to pop up as a solution that a lot of organizations would embrace, right? So some examples here, you see kind of a combination of first party and third party. I say here on the third party side, you see things like worms and I love you, everybody. Anybody old enough to remember the Melissa virus? Anybody old enough to have experienced it multiple times in their own environment and had to deal with that crap? Yeah. And then this Equifax breach that was kind of in the, I'd say like the early 2010 timeframe, if I remember correctly, somewhere around 2012, 2013 timeframe. And this was kind of an example of an early first-party risk associated to having a web application online. Equifax was fully responsible for the security of that application, right? They wrote the code, they deployed it, they installed the environment. They had done the other things, let's say as far as putting a firewall in place, restricting traffic to only the trusted sources, but the trusted sources in this case were kind of anybody. So you put a web application online that's deliberately open to anybody, you're responsible for how secure that application is. If you have an outdated set of admin credentials that you've never changed and you have a vulnerability to a SQL injection in a login form, that's on you, right? So that's the first party risk that we saw there, right? So we see various flavors of this. I'm just highlighting a few examples to kind of illustrate the first party, third party risks around that. Then we started to move into the cloud. And I would say in the early days of moving to the cloud, let's call it in the kind of 2010 to 2015, 16, 17 timeframe, a lot of organizations went through a lift and shift. Is anybody bold enough to admit that their organization lifted and shifted into the cloud at that time frame? Yes, good on you. I think you're the only honest one in this room. I'm sure at least like 25, 30% of the people in this room, if you're like honest about it, you know you lifted and shifted. Not everybody transformed and went cloud native as they migrated to the cloud, right? But what you saw in that time frame was a beginning of a loosening of access and controls. What I mean by that is it was no longer the case, or it started to no longer be the case, that you had to go somewhere to get permission to stand something up, right? You started to see more distributed access, developers getting keys to go and AWS logins to go build things on their own, right? And we started to have a different set of challenges and risks around it, right? And we're going to talk about some of those in a second. So if we think about like what happened in that wave of cloud security breaches in the mid-20 teens, well, we had our first party common things, right? Remember, you're responsible for your security in the cloud. We had an endless supply of open S3 buckets. Anybody willing to admit that their organization left an S3 bucket open to the world? Cool. I see one hand in the back. I won't point out who. Good on you for being honest about it. But lots of organizations made these kind of accidental configuration mistakes at that time frame. And why? Because it was hard. It was a different type of risk. And this is one of the other key learnings that I've come away with as I walk through kind of these phases of evolution. If we think about this risk of a misconfigured S3 bucket, and we think back to what we had in the kind of phase one timeframe as far as security tooling, absolutely zero of these security tools were prepared to address the misconfiguration risk, the first party risk that the organizations had as they went into the cloud, right? Nothing in that tool stack would tell you you've got an S3 bucket open to the world. And so with each of these phases, you end up with a new set of risks, a new kind of threat model, if you will, and you end up having to adopt new security tooling, whether that's homegrown, whether that's third-party commercial off the shelf, open source, what have you, right? And then what inevitably happens is that you get past this kind of initial wave of like, oh, okay, we have these kind of, let's say, like typical user error problems or teething problems as we've learned to use this new technology platform. And where does that leave us? It leaves us where we're getting better at managing our own security in the cloud, but the threat actors understand this as well, and then they get more sophisticated. I always tell people, remember, your threat actors actually have cloud now as well. They have access to all the same cloud platforms as you. They might use stolen credit cards to get there, but they do have AWS accounts, they do have GCP accounts, they do have Microsoft Azure accounts, and by the way, probably like a limitless set of funds to get after them, right? The market for stolen credit cards is robust, let's say, right? And so we move from the simple misconfigurations into more third-party risks. And I'll admit it's somewhat debatable, like who bears ultimate responsibility for that, for all the phases of the Capital One hack. I don't know if people have spent a lot of time analyzing it, but it was a very educated and informed threat actor who knew how to navigate AWS quite well, knew how to pivot from an application layer vulnerability to an instance-based command line access to then discovering an IAM role and then leveraging that role to access the data, right? So you could arguably put a first party and a third party risk on that one. But the point is, threat actors know how to use cloud now as well. So you now need to plan to mitigate against educated attackers, right? This cloud phase, I like to say that this is kind of the first time that security teams face this kind of dilemma. And the dilemma is that you have kind of a tortoise and a hare race. Everybody remember tortoise and the hare fable, right? About the two teams racing each other, or the two animals racing each other. I liken this to business units and developers versus security teams. And what we've seen with starting with cloud and now evolving into, let's say, like modern cloud, and we're going to talk about AI on this aspect as well, is we see that new technologies get introduced. They hold a ton of promise and potential. Business units adopt them well before security teams know how to deal with them. And so what we have is the hare jumping out front, the developers jumping out front to use the cloud. And we have the security teams, the tortoise, sadly, kind of struggling to catch up with them. Now, if you remember the fable, eventually the security team does catch up and things get kind of managed well enough within these organizations. But I think it's a pretty apt comparison. Then we moved into the phase that I call the phase of APIs, but you can just think of this as kind of like cloud 2.0 or cloud native or modern cloud, or however you want to think about it, digital transformation if you want to use a buzzword. But eventually, like most organizations, they went through their lift and shift. They get to running on the cloud for a little while. And what ends up happening is they realize, hey, I'm not getting all the flexibility and agility that I was promised from this cloud platform. We have these long-lived workloads. We're really like not running any different or better than we were on-prem. What gives? And then they realize actually the problem is them and their software architecture and also maybe their operations model, right? If you're operating in a data center mindset on the cloud, you're not going to get all the cloud benefits. Similarly, if your software stack is very monolithic and doesn't really support scale up, scale down, you're not going to get all the benefits out of cloud. So organizations kind of embrace what I call cloud 2.0. They start to refactor their applications, break them down, microservices, serverless container, however they end up doing it. Could be platform as a service offerings at this point. But by the time they reach this phase, you typically see fully distributed access models. You start to see it where actually now we understand how to use IAM on cloud platforms, and we know how to give you, Joe or Jane developer, we know how to give you the right set of credentials and the right set of access that's going to let you deploy into development, testing, staging, and then we know how to do infrastructure as code and automated deployments. And then we, the security team, we now know how to put in place all the right controls so that you can't screw things up in production, and we have all the monitoring access that we need, right? So you get better and better over time. But now we look at kind of like more complex attacks that start to rise above even leveraging the infrastructure layer like we saw in the Capital One case, and we get into attacks where we're focusing on application layer constructs that are very specific and do things like exploit flaws in business logic. And we're going to talk about a couple examples in a second. And we get into a phase where actually like even CSPM that we had for managing our cloud misconfigurations doesn't give us all the visibility that we need to understand, let's say, correlated vulnerabilities and whatnot, right? So we see things like a breach from a large telco in Australia, where actually something like 40% of the Australian population's data was exposed. Small country, so like 10 million people is roughly 40%, if I remember right. And what you saw here was that actually API vulnerabilities, kind of like design flaws in the APIs, were the entry point, coupled with a network misconfiguration, coupled with like really some poor practices around sequential integer numbering of records. How many people have built an API? Awesome. Keep your hands up if you have used your database table's primary key as the identifier in your request parameters, and you're willing to admit it? Yeah, we've got a couple hands up in the room. This is, by the way, like if you couple that with no server-side authorization check, you have the single greatest toxic combination for having your entire data set breached by a threat actor, right? So once I'm authenticated to your API and you are not requiring me to check my authorization on every data record that I am accessing, it is as simple as writing a for loop where I iterate over every ID number on whatever request parameter you have to get the record ID, and presto, I have your entire data set. So we see these types of breaches start to take effect, and we understand, again, threat actors are keeping up. So first-party risk, you're responsible for the design of your API, and that is kind of where that has gone. I'm not going to spend a lot of time. This was another case. What I am going to talk about here that I think is really interesting is that just like the threat actors eventually catch up to understanding the new technologies, eventually, and I know it takes years, the regulators will catch up to this as well. And this was a really interesting observation from 2024 where the FCC, which is the regulator for telecommunications, finally clamped down on an organization and said, hey, Verizon, or in this case, TracFone, which is a division of Verizon, your APIs were really bad. You screwed up and leaked data off of your APIs multiple times. You have to get them right. You have to undertake to improve your cybersecurity posture specifically around your APIs, or you face regulatory action, right? So how many people work in regulated industries, which includes all things government? Yeah, I expect that to be like half the room, right? One interesting observation, which we haven't seen yet out of this API security kind of clampdown, is that typically, once you see regulatory action in one space, it tends to spread to the others as well. It might take a while to get to government. It'll probably go from telecommunications to something like financial services or healthcare next. But it's usually a question of time, like a question of when, not if, right? And one interesting thing around this phase of kind of, let's say, like modern cloud technology stacks, I mentioned that a lot of the risks are kind of the first-party risks in the design of the applications. We took a threat model of what's called the OWASP API Top 10, and we tried to plot it out to illustrate one point that I've referenced already. When you look at this threat model, you'll see that like 8 out of 10 of the risks are actually within the server, and in fact, quite a lot of them are around particular behaviors like authorization, validation, and sanitization of inputs, and around, let's say, like data retrieval and execution of functions. These are all business logic things that are happening and defined like within the application. So these are not your typical infrastructure or network or even your like cloud infrastructure security threats, right? In fact, only 2 out of the 10 can even be inspected at the network layer. So just for those who are curious, and I'm not going to spend a lot of time on this section, we've been doing an annual study of the state of API security every year for the last 3 years. The one that we're working on to review 2024 is actually coming out in the next couple of weeks. I'm not going to spoil what's in there, but suffice it to say that the risks around APIs have actually been growing year over year. And as I mentioned, one of the problems with APIs is that when there is a flaw, it tends to be the type of flaw that exposes an entire data set. So the size of an API breach is typically 1,000 times larger than the quote unquote median data breach, because again, it usually exposes the entire data set. If you're curious, feel free to hit me up or check our website in about a week and a half, 2 weeks, and the 2024 State of API Security will be out there. I'm not going to spend too much time on it right now. I will say one very interesting analysis that we've done is we kind of analyzed along the lines of number of breach events. And there you see that authentication and authorization are kind of in a dead heat for first place. But when you pivot that to look at number of records, authorization shoots way, way up. And it's again that toxic combination that I mentioned of like no server-side authorization checks is like really the number one common thread across all of these breach events. I'm going to skip this because we already talked about that. For those that are curious, this is the OWASP API Top 10. I'm not going to spend time on that either. Oh yeah, for those who are actually looking, who are like thinking, oh yeah, crap, we need to actually kind of audit and inspect our APIs. Finally, last year, for the first time, there was a publication of a more prescriptive set of API security controls. Like, whereas the OWASP API Top 10 is just a set of risks and threats around APIs and what can go wrong, this is a set of prescriptive controls that you can actually use to inspect your own APIs and measure how good or bad you are doing with regards to your APIs. If you're curious, that's the community to join. It is an open community for anybody who is a practitioner and is interested in the topic, you are more than welcome to contribute, join into the discussions over there, etc. I don't know why, but that's how their communities are done. 202. Look for community 202 on the CIS, and that's what you're looking for. Awesome. That brings us to kind of where we are today, right? And I know it took a little while to kind of get to where we are with AI, but I think it's useful to understand the context, because there's one real crucial connection point between APIs and AI. So now where are we? We're in this kind of era of cloud, and let's say cloud native plus AI. And we're moving into kind of like not only a cloud native operating model, but an AI ops model. And you're hearing a lot of organizations who are saying like, hey, we're going to be measuring data in real time, reinforcing learning by sending data, like newly ingested data, into an LLM or into a RAG augmented LLM system, so that we can make more data informed and better decisions. And one of the real challenges around AI right now is like, we're past distributed. We're really at the era of release the hounds. How many people are using AI on a regular basis in your day-to-day work? So like 2/3 of the room. How many of you are using it in, let's say, programmatically, meaning that you're building applications that integrate with LLMs? Cool, about half of that audience. And how many are like chat in your browser, upload a document to ChatGPT and summarize this document, whatever? Yeah, so a little bit more than half, right? And look, I'm doing the same, by the way. I actually had to download a set of PCI guidelines around a new security standard that they're working on, and it was like 30-some page document. I 100% uploaded that thing to ChatGPT. It said, summarize this and give me the controls that are in this document. And it makes total sense, right? But to my point, like, we're past the asking for permission to get what I need to get in order to do my job. We are very much at the like wild, wild west of anything goes within your environments. And I would argue that one of the real challenges around this, and this was a stat I can't take credit for, but one of the real challenges for a security team is something like 90% of all AI usage is happening outside the purview of cybersecurity teams. So security teams within your organization don't know who's using what, where, and with what data. They don't know that I'm uploading that PCI document. Maybe nobody cares about that PCI document, but they 100% care if I upload an HR spreadsheet, right? So these are some of the challenges that we're seeing around this. Now, I mentioned earlier that hackers have cloud. Hackers have AI as well. And in fact, like you might, if you've been paying attention to this area, you know that there are some open source LLM models that have been circulated around. One of the early ones that kind of got a lot of media attention at the time was something called Fraud GPT, which was kind of a forked version of Meta Llama that was specifically had the guardrails removed from it, kind of the ethical guidelines. If you've ever played with one of these models to try to tell it, hey, write me a phishing email, most of them will tell you right away, I'm not allowed to do that. Very similar to the like 2001 Space Odyssey. I'm afraid I can't do that, Dave. And you know that those guardrails were removed. The model was trained with some malware samples in order to produce better quality malware that does things like evade detection on endpoints and so on. So we're entering an era with a lot of challenges. So this is an AI-generated image of security teams rushing to keep up with developers who are using AI. I just thought it was fun to include here. I also think it's really weird that effectively everybody who works in cybersecurity looks pretty much the same. Like pretty much the same. They all have basically the same glasses, haircuts, shirts, etc. The other thing that I think is weird is that their mouths are like 100% weird, right? Like every one of them has the same mouth, and I don't know, like, yeah, we're screaming to keep up with them. Oh yeah, this guy is missing hands, right? Yeah. Anyway, and this guy, I don't know, his. Anyway, we could spend all night looking at it. But I mentioned that one of the challenges around where we are right now, as we move through this cycle of technology adoption, is this question that there is no AI without APIs. And what I mean by that is this is a reference architecture for an LLM integration in, let's call it an LLM augmented application, right? So we have a business app that does whatever. Could be a shopping cart, could be a recommendation engine, could be whatever it is. But when you look at how you actually do things like train it with data, how you call it, how you either share data, invoke functions, etc., these are all API calls. And in fact, as we've talked to organizations over the last year or so, the number one growth use case of APIs that is leading to this mass proliferation of APIs is AI usage and LLM adoption. So all of this brings me to what you really came to talk about tonight, the double-edged sword. There's a question that I've been asked a few times, and I've talked to a couple of other people who are more accomplished in cybersecurity than I am, which is who gets the advantage of AI? Is it attackers or defenders? How many people think it's attackers? How many people think it's defenders? So we got like 10% vote for each. So I think like 80% of you either are asleep or don't know or are so confused at this point that we don't know what's going on. But look, I think that the truth of the matter is there are pros and cons, and that's kind of the double-edged sword that I want to talk about. But I think the most interesting piece of feedback that I've gotten from people is whoever embraces it first and does the best job of augmenting a foundational model with relevant training data and then operationalizes that, so to speak, most quickly is the organization that wins the most. That might be attackers, that might be defenders. Let's talk about some of the examples. So when we think about some of the positive impacts, right, and we go through that kind of mental exercise of first-party versus third-party risks, we realize that one of the biggest risks that we're facing right now is the design of our applications. Remember, that's a first-party risk that we as organizations are responsible for. How, quote-unquote, secure by design are we, right? So one of the bright sides about AI is that AI is as good as the data that it's trained on. One of the number one data sources that most LLMs have been trained on is things like GitHub, public repositories of source code. So if you think about kind of taking all the source code that's been sucked into these LLMs that they've been trained on, and you look at like telling it, these are good applications, these are bad applications. Here's an example of an application that does a great job of managing inputs and sanitizing and validating, and then even verifying the response payloads and blah, 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 all the security controls that you would want to have in your application. Very, very easy for an LLM to kind of replicate that and spit that back out, and then also assess new code that you're feeding into it. Is my code written well? Right? Great example. Second thing, incident summarization. How many people have been through an incident response exercise? Being breached in the real world? Yep. How painful was it to do the initial response where you had to gather log files, look through them, maybe log files from multiple systems, put them in sequential kind of chronological order, and then figure out what actually happened there? Super painful, right? I know for me, when I've been through a couple of my own, annoying. Operating system logs, application logs, Active Directory audit trail, etc. Put all of that together to understand what happened. Well, guess who's really good at that? LLMs. Let me give you 5 log sources. You can do the hard work of putting them all in chronological order, and then tell me if I point you out one of the log files that is relevant for my investigation. You go tell me all the other connected ones. Tell me what happened here, and give it to me in human language that I can understand. Oh, threat actor sent a phishing email to Jeremy, and Jeremy clicked the link and gave his credentials, and then the threat actor came back using those credentials, blah, 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 blah. Super easy, very helpful, allows you to get past that initial log inspection phase and into response, right? Super powerful. If we think about things like analyzing mass volumes of data, give an LLM a bunch of log files, tell it ones that are indicators of attack or compromise, IOCs, and then tell it, watch out for all these coming in across all of these systems. I don't want to spend hours of my day looking at log files. I think anybody in the right mind doesn't want to do that as well, right? But an LLM can do that until the cows come home, right? So you think about kind of attack detection. Similarly, you think about telling that LLM, great, now you have weeks, months of history. Give me some predictive stuff. You know what my attack frequency looks like. You know what types of attack I'm facing. You know where those attacks are coming for by, let's say, IP address or maybe geolocated lookup or something like that. Give me some predictive analysis around that. All of that, super helpful. This is stuff that companies are already doing, and this is stuff that also cybersecurity vendors are already incorporating into their products, right? So if you're using some commercial stuff today, you're probably already benefiting from some of this stuff. And if you're not, or if your vendors don't have them, you should be asking them, hey, like, why can't we get stuff like this? For the most part, I think it's just a question of time. But there are some things that are challenging for an LLM, right? An LLM is only as good as the data that it is trained on. So when we think about attackers adapting to new technologies, you can be sure that the types of things that are hard to detect, let's say programmatically, are going to be where attackers move. So think about low and slow, live off the land, these types of techniques where we don't try to fetch an entire data set all at once because that triggers all kinds of alarm bells, but we think about maintaining access that looks like normal behavior over time. That's very hard for an LLM. Authorization turns out to be a particularly challenging problem for an LLM, mostly because authorization relies on having a real-time understanding of who is allowed to do what with what data. It is a particularly challenging IAM problem, and LLMs in our experience to date are not great at that. And then one other challenge is true anomalies. Anytime you have a system that is trained on patterns of data over time, the first time always looks weird. The first instance of something always looks weird. So if you trigger your alerts off of something like that, you're prone to getting a high volume of false positives. Okay, let's talk about the negative impacts. I focused in this section a little bit on APIs because it is the thing that I kind of know best. One challenge around this is that these coding assistants are great. I just picked this service, and I don't mean to really pick on them by any means, because really, like, any of the coding assistants and copilots are pretty much around this, but everybody can write an API right now, right? Everybody in this room could sit down, conceptualize something that you want to have available in the world, go to any number of LLMs and tell it, build me an API to, I don't know, like, fetch the time in Sri Lanka and give me the weather for some location, right? Very, very easy to build with an API right now. There's a flip side to that. And by the way, like, you can not only build an API, but you can build something to query an API. You say, hey, there's like 1,000 integrations available on Zapier. Write me code to go query Zapier or go query Twilio and fetch this data back. So I can build APIs, I can build code to integrate and query APIs. So you get an API, everybody gets a Gen AI written API. Well, what's wrong with that? Well, what's wrong with that is that actually all of the research so far shows that AI-generated code is less secure than human-generated code. Now, this might be a temporary feature, right? This might be where we are right now. And it might also be the case that your code is going to be as secure as the prompts of the person who writes it. So if you give an LLM explicit instructions, write me an API that sanitizes, validates, checks authorization on every single request, you may have better results. How many quote unquote vibe coders really think to do that, right? Like, that is not the reality of what I think we can expect realistically right now, or what you can expect to see within your own organizations. If you want proof of this, by the way, there's kind of a funny thing. Like, I don't know how many of you have been following a lot of the bold predictions around AI, right? Anybody hear about this single person unicorn company concept? Yeah, like, you're gonna have one person who just imagines a SaaS application, goes to an LLM, builds it, writes it, operates it, deploys it on the cloud, and this person doesn't even have to be technical. They don't even know how to run AWS because the LLM will tell them how to do it, right? So I could build some company hypothetically worth $1 billion just on my own. I don't need a team. I don't need anything. I can get an LLM to do all of it. So here is the first, let's say, real world example of this. I did go and look up this service, by the way. The service is called enrichlead.com. If you're curious, you can find actually the tweet or whatever the heck it's called nowadays. So this is somebody who built a SaaS offering with Cursor, was actually able to get a SaaS offering online and get people to pay for it, and then bragged about it. Well, the internet does as the internet does. And when this boast was put out there, a bunch of people were like, let's poke around. And sure enough, shock surprise, the AI written code was not as secure as they might have thought. And so I loved this line in particular. As you know, I'm not technical. It's like, okay, great. I mean, so you're, I don't know, blaming the LLM? I don't know what you want here, like as you just kind of put this tweet out into the world. People who inspected it found, like, just very, very quickly, hard-coded credentials that were in the code repository committed by the LLM, and then no authentication on several of the API endpoints. So yeah. Another risk that's coming around it is your AI provider might not be 100% secure. So it's the first third-party risk that I've seen around LLM so far. There's a lot of talk, by the way, about, let's say, things like LLM hallucination and toxicity. Those are also third-party risks, to be sure. I just wanted to highlight here that kind of arguably the leading company in the space, ChatGPT, only shows up with a 48% privacy score and 2 out of 5 on a kid safety score, and 3 out of 5 on the overall security rating here, right? Now, this is a little bit dated. I think they've gotten a little bit better since then. But you can look up and down this list, and you'll see all kinds of model providers. And a lot of model providers are specialized for a particular scenario, like Stable Diffusion here at the bottom, I think is particularly used for generating images and kind of like background video stuff. 1 out of 5 security score, like, not ideal, right? So another thing, this is another example of kind of a third-party risk. There's obviously an arms race going on in AI right now. I don't think a single week goes by without at least like 4 or 5 new model, new version, updated this, more token size that, greater capabilities, blah, 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 blah. 4 or 5 of these announcements, or something like one of the cloud providers saying, hey, we've now just onboarded this model provider and this model provider and this model provider, and they're now available serverless or whatever. All of which, by the way, is great stuff. Like, it is great for a consumer of these services that there is this arms race going on, because it's bringing us new capabilities day by day, literally day by day. Fantastic. I've never experienced so much innovation happening so quickly in my whole career, which is fantastic. But in that race, there is kind of a move fast and break stuff attitude going on right now. This is an example of a service that was designed to help customers move their own data into a place where it could be read by LLMs for better results, right? For more kind of, let's say, customer tweaked results. In that rush to create the service, to onboard the data, there was a single misconfiguration in the service itself that allowed any user of the service to access any other users of the service data, simply by changing a user ID in some of the API requests, right? And so, like, this race to get ahead, this arms race to have the latest and greatest, also comes with risks of its own. There is also a real risk of AIs being kind of hacked and jailbroken. I won't go through all the details on this one. I do encourage you to go read about this one. That's the URL to go check it out. The TLDR is compromised credentials, jailbroken LLM, sex chat service hosted on a site that the attackers controlled, but the LLM hosted on a site of the compromised AWS customer, who ended up paying the bill, by the way, for the sex chat service. One more example, I'm going to assume everybody in the room is familiar with ChatGPT. One of the things that it does is it crawls websites regularly to get more and more text to get trained on. There is an indexing API that you can call and request that it index your website, presumably. But guess what? That API doesn't require any kind of authentication, so anybody could request anything. And you could also give it your competitor's website. You could give it your competitor's website 25,000 times. There's no deduplication on the input. And if it gets a request to index 25,000 websites, it will parallelize the request, send out 5,000 requests per second, resulting in effective DDoS. You want to take down your competitor's website? Go have it indexed. A lot. Last couple of examples. This is a capture the flag exercise. When given the right set of prompts, ChatGPT actually went and leveraged a known vulnerability inside a container to get into the container. And just recently, that one is a few months old, but just recently, this is just from a couple of weeks ago, somebody took a piece of malware that was specialized for a particular technical environment, operating system, particular app that it was targeting. Stripped away all the particulars around it, just went down to the core malware, right? So the kind of the bad package, if you will. Told the LLM, take this package, get into that machine, I don't care how you do it. And sure enough, the LLM found a vulnerability that was very recently disclosed. They gave the LLM command line access via terminal emulation. And the LLM, sure enough, wrote all the CLI scripts to execute. And I love that this guy, Claude, just zero-shotting format string exploits. So yes, these LLMs have these safeguards. So far, it looks like it's not that hard to go around these safeguards. You should expect that all threat actors will be AI powered. So I mentioned earlier, hackers have cloud. I always tell people hackers have cloud, hackers have automation, hackers have AI. All the things that you have that you think are awesome and that you're using for your defenses, your quote unquote adversaries have them as well. Forrester talks about this connection between AI and APIs, I think quite succinctly. Your AI strategy will crumble if you neglect API security. I'm going to skip forward. I just wanted to go back now. So I mentioned before, as we go through these phases of innovation, the tooling that we have for each phase in response to the threats typically doesn't keep up with the next wave of threats. So this is the OWASP LLM top 10. This is the new set of threats that the OWASP OWASP steering group is warning organizations around. And I think what's interesting here is that you see quite a lot that's still at the application layer. Quite a lot of it is still around some of the things that are present within APIs. We think about like tokenization, masking, sanitization, rate limiting, all of these things that are very API related, and then a new set of things that are very AI specific. So we have things like guardrails, model training, the data that's going in there, corporate data, knowledge bases, etc. But the point is we have a new set of threats that is primarily first party that your existing tooling does not handle. So like every wave of innovation, awesome, unleashes new technologies. Every wave of innovation, oops, brings new threats that you're typically unable to handle. All right, so where does this leave us? We're now in the present scenario where a couple of things, vulnerabilities, MTTR, meaning mean time to remediation of vulnerabilities, is still 180 days. Shameful, it has been that number for more than 20 years. That is the mean time towards patching a vulnerability on a system in production. That stat has not changed in 20 years. Yet, MTTA, mean time to attack, is now down to 22 minutes on average. So from the time that I announce, oh, we've discovered a vulnerability in, I don't know, log4j, well, I need exploit code. That time period from the announcement to the availability of the exploit code is now as low as well, it's probably lower than that because that's the average, right? So there are certainly scenarios where that is very, very low. Second, any new wave of technology, one of the first kind of mitigation techniques that comes along is something called security posture management, which we'll talk about in just a second. Most of the time, organizations have double the number of resources, and of those resources, 20% already have issues. So if you think about this, if you say I think 100 people in my organization are using AI, once you turn on some detection tool or some discovery tool, you find actually 200. And of those 200, 40 of them are doing things that are not good, right? So that is kind of another stat. APIs, we've talked about a little bit. I'm not going to dwell on that. AI, kind of where we're going right now, right? I mentioned earlier, the current stats are showing about 90% shadow AI usage today. New threat models, new attack types, everything coming faster than ever. So, yeah. No worries, gave me an opportunity to get some water. Okay, so securing new tech. So what are some strategies that I've kind of learned and observed as I put this talk together and I thought about these challenges for each of these waves? Number one challenge is always visibility, right? So you think about that 90% stat. We don't know what's going on, who's doing what, where, with what models, et cetera. Always starts with visibility. If you don't know what you have zero chance of actually kind of mitigating risks around it. But number two, once you've got visibility, assess the risk, understand. Okay, we're using these models and these providers. We're using DeepSeek. Oh crap, is that a risk to us? Maybe it is, maybe it's not, right? Second is then formulating some policies for your organization. What is acceptable for us as an organization? And then we can kind of prioritize and think about things to do. Providing ongoing monitoring so that you don't end up in a kind of point in time remediation exercise. You don't want to go through these 3 steps and then have to repeat them 6 months later, right? You want to be monitoring. Once you've got your handle around something, you want to have some monitoring in place. And believe it or not, I know that the instinct is, well, let's protect the organization. Let's put in place some kind of preventative controls right now so that people can't just go willy-nilly do what they want to do. I will tell you that strategy, in my experience, the more successful approach is go through these steps first before you try to like really lock things down. If you try to lock things down right now, people will just go around your controls. That will happen in your organization. Awesome. I'm going to skip over these because I think the last slide really kind of handled it. For those who are curious, and this will be the only Firetail kind of talk that I do, if you are curious and you want to try to tackle this problem, we have some capabilities to help you build an AI inventory across your providers, models, prompts, understand the data that's in use in OWASP LLM Top 10 risk scoring framework that we're using, as well as doing things like detecting leakage of PII, anomaly detection, and so on. So that is just a little bit about us. We're a locally headquartered cybersecurity company. We were founded in 2022. I hope you've enjoyed the talk. I'm going to leave this QR code up on the screen and take questions now.